Your little one-on-one session today, Preston.
We're doing it. Where the hell's everyone else?
Playing hooky, I guess.
All right. We are recording. Perfect. I will go ahead and start screen sharing. Awesome. Okay. So ReplicaSet in Kubernetes is a resource object that ensures a specified number of identical pod replicas are running at all times. It is a higher level abstraction built on top of Kubernetes pods and provides a declarative way to manage and scale multiple instances of pods. The main purpose of ReplicaSet is to maintain the desired state of a set of pods, even in the face of failure or failures. Changes in demand, it continuously monitors the status of its pods and automatically adjusts the number of replicas to match the desired count. What does this sound like, everyone? Someone like AWS.
Ansible. No?
Say that again.
Ansible?
Yeah, I guess you can kind of relate to that. To me, it kind of sounds like auto-scaling and load balancing. Just say something fails, it just respins up another one, right? Or we set our limit on CPU, it hits this amount of CPU, we spin up another instance. So that's the way I like to think of it for its own like Kubernetes versions. Okay. To create a replica set, you define its specifications in YAML or a JSON file. Then use the kubectl command line tool to create or update the resource. So we have in this little diagram here, we have replicas is 3, right? Desired replicas is 3, current replicas is 3, current equals desired. So we have 1, 2, say that one cancels out, we'll spun up another one right away. And then we'll go ahead and deploy this. So I already have this up. Made a replica.yaml. We open that up. We have our API version, which is apps/version1. Kind, we're doing a replica set. Metadata, so just our names and labels, right? We're doing nginx pod. App equals nginx replicas. Specs, replicas is 2. So in this case, we will always have 2. We'll always have those same 2 pods running at all times. If one fails, it's automatically going to spin up another one. And that's just running on 80. So we X out of here. And then we can do some commands. Let's make this a little easier to see for you guys. So then we'll do a kubectl apply attack F for our file, right? We're doing the replica.yaml. Spins right up. We can do a kubectl get replica set. This is where it shows us how many replicas, what's our current state, how many already. And then we can also check our pods. And we have 2 pods. Running the exact same, let's see how there are 2 different pods. Say one becomes degraded, it's automatically going to spin up another one. Yeah. I'm going to go ahead and spin these down. That'll spin down everything that it created just by the file. I'm going to pause the recording. So now we're diving into services in Kubernetes, the different service types. In Kubernetes, a service is an abstraction that defines a logical set of pods and a policy by which to access them. Kubernetes services enable pods to communicate with each other and with the outside world, even as pods are created, destroyed, or moved. So service types in Kubernetes, or K8s, K8s is short for Kubernetes. We have a cluster IP, which is default service type, exposes the service on a cluster internal IP. It is only reachable from within the cluster. And we have node port, exposes the service on each node's IP at a static port. This makes the service accessible from outside the cluster using a load balancer, and then we have the load balancer. It creates an external load balancer if supported by the cloud provider that forwards traffic to the service. We have external name, maps the service to a DNS name instead of a traditional selector. We have a nice little diagram here. Then we can go ahead and deploy something like this. So in this lesson, we will create a deployment service. Today, finally, all the pods we have been creating will be visible as an app. This is kind of how it works. You get an incoming request, you have our cluster, they access it through the node port, hits the service then serves what is going on inside of our pods, or the application in this example. So we're going to create a deployment manifest file. I'm going to go into my service directory. Here's our deployment file. So same thing, API version still FTP1. Our kind is deployment. Metadata, we're naming it Nginx deployment. The apps is Nginx dep for Nginx deployment. Spec replica, we're just going to have one. Match labels, apps can be Nginx via dep, or for short for deployment. Same thing there. Specs containers. For the image that's going to be pulling, it's going to be using Chandra's Docker image that's serving Dojo Jump. This is version 3. And then we're going to create our service manifest file right here. So that's API version, just one, same thing. Kind is service. Metadata, name, we're just naming it Nginx service. Spec selector app via dep. See how that matches, right? Type, it's going to be on no port. The protocol is going to be TCP port 80. Target port's 80. Node port is 30,003. So if we run EQ, CTL, TAC F, I'm doing a dot for this current directory. It's just going to deploy all my files in this current directory. Oh, sorry, I forgot to apply. So now those are created. If we go down here, then we can get our URL from the Nginx service. If I control and click that, and we have Dojo Jump, which is kind of crappy, but it's running, right? You guys can see it. That's pretty much about it. Any questions? I'll go ahead and pause the recording.